Welcome you all in lecture number 29 of Abstract Algebra MTL 6051. In this lecture we will going to discuss one important theorem related to PID, right? Every principal ideal in PID is maximal ideal. And second one, what is the prime element? And third one, what is irreducible element? And fourth, is there any relation between prime and irreducible element? Okay, so let us see first the theorem. We have to show that in PID every non-zero prime ideal is maximal ideal. Okay, let us see. If we say R is PID, R is principal integral domain, and P is prime ideal, such that this P is generated by small p. Okay, and this small p is non-zero. Okay, then we have to show that this P is maximal ideal also. Okay, let us assume this P is not maximal. Then what happens? There exists Q, ideal Q, such that P is subset of Q, Q is subset of R. Okay, this P is subset of Q, Q is subset of R. Okay? If this P is not maximal, then what is Q? Q is also an ideal of PID, and every ideal of PID is generated by a single element. This is generated by Q. Okay, and this P is generated by P. Okay, then what is Q? Q is any other ideal of this R, and R is PID. Okay, this Q is subset of R. Yes, then since P belongs to capital Q, why? Since capital P is subset of Q, P belongs to Q, then this Q divides P. This implies that P is equal to QR for some R. If Q divides P, then there exists R such that P is equal to Q into R. Okay, then see, what is P? P belongs to capital P. It means Q into R also belong to capital P. So either Q belong to P or R belong to P. This Q belongs to P or R belongs to P. Okay, if Q belongs to P, first condition, if Q belongs to P, then P and Q are equal. Okay, then P and Q are equal. And if R belongs to P, then R equal to P into T. Since R belong to P, capital P is generated by small p. So R equal to PT for something. Then what is P? P is Q or T. It means 1 is equal to Q into T. So 1 belongs to Q. And if 1 belongs to Q, then Q is equal to R. So if Q belongs to P, then Q is equal to P. Then Q equal to P. And if R belongs to P, then Q is equal to R. Right? Which shows that capital P is the maximal ideal. Right? Our principal integral domain R. Okay. Now let us see what is the prime element, what is the irreducible element. Okay. Come to the prime element. See prime element. Let R be a commutative ring with unity. What is R? R is commutative ring with unity. Okay. R is commutative ring with unity. Okay. an element P belongs to R. Now remember that R is commutative ring with unity. An element P belong to R is said to be prime. Is said to be prime if it satisfies two conditions. What is the condition? See, P is neither 0 nor unit. Remember that P is neither 0 nor unit. Okay, unit means its inverse does not exist in R. Okay, this is the first condition. And second condition, if P divides AB, means product of AB, where AB belongs to R. If P divides AB, then this implies that P divides A or P divides B. See, this is the condition of prime element. Now, let us see once again what is the prime element. An element P of R. What is R? R is commutative ring with unity. The P belongs to R is said to be prime if P is not 0. First, P is not unit. P is not 0, P is not unit, and for any two AB belongs to R, if P divides AB, then P divides AB, see this condition, P divides AB, then either P divides A or P divides B. Okay. Now come to the irreducible element. Right? If R is commutative ring with unity, an element P belong to R is said to be irreducible. What do you mean by irreducible? First condition is same. P is not 0, not unit. What is P? P is not 0, not unit. And second condition. In here, second condition is P divides AB, then P divides ARB. But in case of irreducibility, if P is equal to AB, then either A or B must be unit. At any time, if P is equal to AB, then either this or this is unit. Okay. Then this P is said to be irreducible. Okay. Now let us see what is prime element, what is irreducible element. These are the definition. Whether these two elements, prime or irreducible, are same or something different. It depends on the domain. Okay. So if we consider Z plus and dot. What is Z plus and dot? This is commutative ring with unity. Commutative ring with unity. Okay. Yes. Then this is commutative ring with unity. In this commutative ring with unity, every prime element is irreducible. Okay, means in Z plus dot, prime element implies irreducibility and irreducible element implies prime element, means both are same, right? But whether it is true for the other domain also? No, right? Let us see. Z square root of minus 5. Z square root of minus 5. What is the element of this? A plus B square root of minus 5. We already discussed about Z root 2. What is this? This is A plus B root 2. AB belongs to Z. This we already discussed. Similarly, here Z minus root 5, that is A plus B minus root 5. Okay. So this one. Now element of this is of this form. Then this Z root square root of minus 5 is commutative ring with unity with respect to these two operations. Addition, sorry, this one is addition. Addition operation is defined as follows. Okay, and multiplication operation is defined as follows. Okay, so with respect to these two operations, this Z square root of minus 5, which containing these type of element, is commutative ring with unity. Okay. Now let us see. If any element of this is prime, then whether The prime and irreducible are same. Now see the example. Now let us see the example of prime element. Okay, we are talking about z square root minus 5 containing all those elements of the type a plus b square root of minus 5 ab belongs to z. Okay, then this square root of minus 5 is prime element. What is this? This is prime element. Okay, so for prime element we know that if p divides ab, then this implies that p divides a or p divides b. This is the second condition, and first condition, p is not 0 and p is not unit. So this square root of minus 5 is not equal to 0. Okay, and next, if this square root of minus 5 does not unit also. Why? Let us assume it is unit. Now, if it is unit, then its inverse exists. What is the inverse? Its inverse is of the type x plus y square root of minus 5 is equal to 1. Okay, then x square root of minus 5 minus 5y is equal to 1. This implies that x square root of minus 5 is equal to 1 plus 5y. See, this is integer. This is integer, means RHS is integer, but LHS is not integer. Not integer. So these two cannot be equal. It means its inverse does not exist. So this is not unit. Okay, see here. This square root of 5 is not 0. Okay, this is not unit. Suppose if it is unit, then its inverse exists. Say its inverse is a plus b square root of minus 5 or x plus y square root of minus 5, whatever you want to write. Then square root of minus 5, a plus b square root of minus 5 is equal to 1, implies that a square root of minus 5 plus minus 5b equal to 1. Then a square root of minus 5 is equal to 1 plus 5b. Okay, this implies that this RHS is integer, whether LHS is not integer. So this is unit element, sorry, not unit. Okay, so square root of minus 5 is not unit. So it is not 0, not unit. First condition is true. Now come to the second condition. What is the second condition? Second condition says that if p divides ab, then p divides a or p divides b. Okay, see, suppose p divides ab. AB means A and B are two element of where, what is AB? AB are element of R, right? What is our R in this example? Z square root of minus 5. Okay, what is the element of this Z square root of 5? Is the type of A plus B square root of minus 5. So consider this square root of minus 5 divides product of two element of this one. Say the element is a plus b square root of minus 5 and c plus d square root of minus 5. Okay, this is like this. P divides ab. P divides ab. So this is p and this is, say, call it exy. P divide exy. So this is x and so this is y. Okay, then this divides product of this. If this divide product of this, then what it means? It means there exists x plus y square root of minus 5 such that p means this into x plus y square root of minus 5 equal to a plus b square root of minus 5 into c plus d square root of minus 5. Okay, so multiply this term. This is equal to x square root of minus 5 minus 5y. This is LHS. And what is RHS? RHS is AC minus 5BD. AC minus 5BD. And AD plus BC into square root of minus 5. Okay, comparing the coefficient. Okay, AC minus 5BD is equal to minus 5Y. Okay, this thing. See this one. Okay, and catch it. See, 5 divides, 5 into BD minus Y is equal to AC. 5 into BD minus Y is equal to AC. This implies that 5 divide AC. Yes. And this shows that what is 5? 5 is a prime number. So 5 divides A or 5 divides B? Sorry, C. Okay, 5 divides A or 5 divides C. If 5 divides A, suppose if 5 divides A, then what happens? Square. What is 5? 5 is square root of minus 5. Square root of minus 5. This is 5. 5 divide A. Okay. Then 5 square root of minus 5 divides A. Since see, square root of minus 5 square root of minus 5 divides A. Then how we can write this divides A? Since we know that if P divides X, then there exists alpha such that X is equal to P into alpha. What is our P? This. What is our alpha? This one. So A is equal to P, that is square root of minus 5 into alpha. What is alpha? Square root of minus 5. Okay. Then into something. Then this divides A, and similarly this, not similarly, but this square root of minus 5 divides obviously square root of minus 5 divides B into square root of minus 5. Okay, so square root of minus 5 divides A, square root of minus 5 divides B into square root of minus 5. So square root of minus 5 divides the sum of these two also. So square root of minus 5 divides this. Okay. Similarly, we can also show that square root of minus 5 divides this also. Okay. So the second condition, that if P divides AB, this implies that P divides A or P divides this, then this square root of minus 5 either divides this or divides this. Okay. So this is true. It means square root of minus 5 is prime number. Okay. Now consider the example. The element is irreducible but not prime. Okay. Let us see whether such type of element exists. See. Consider 3. 3 belongs to Z square root of minus 5. Okay. Then this 3 can be written as, what is the condition of irreducibility? This 3 is not 0 and 3 is not unit. So first condition is true. Come to the second condition. 3 is product of two elements, A plus B square root of minus 5 and C plus D square root of minus 5. 3 is the product of this. Consider the conjugate of this. What is 3 bar? Then A minus B square root of minus 5, C minus D square root of minus 5. Now multiplying these two terms. This is equal to 9 A square plus 5B square into C square plus 5D square. Okay. Then what is this or this? This is 1, then this is 9. This is 3, then this is 3. This is 9, then this is 1. So the choice of this is 139. Okay. Choice of this is 139. Suppose if A square plus 5B square equal to 1, then what is A? A is equal to plus minus 1 and B equal to 0. Okay. It means A plus B square root of minus 5 is unit. Okay. We know that the condition of irreducibility, P is equal to AB, A into B, then either A or B is unit. Okay. So see, 3 equal to A into B, right? And if A square plus 5B square equal to 1, then this is unit. If c square plus 5d square is equal to 1, then this is unit. So these two possibilities are finished. This is not possible. This is not possible. What is a square plus 5b square? 3. A square plus 5b square equal to 3? It is not possible. So a square plus 5b square 3 is not possible, right? A square plus 5b square is 1, okay, plus minus 1, and a square plus 5b square is plus minus 1. A square plus 5b square is either plus minus 1 or what I am saying, a square plus 5b square equal to 1, then this implies that a is equal to plus minus 1, that is a plus b square root of minus 5 is unit, and if c plus c square plus 5d square equal to 1, then c plus d square root of minus 5 is unit. Okay, it means either this is unit or this is unit, either this unit or this unit. Okay, any one of them are unit. And suppose if a square plus 5b square equal to 3, then they are not unit. Then what we will do, see whether a square plus 5b square equal to 3, a square plus 5b square equal to 3, it doesn't have this solution. Why? A square plus 5b doesn't have solution in z. So what is a and b? A and b are integer. So no integer can be possible for a and b such that a square plus 5b square equal to 3. So this is not equal to 3. So a square plus 5b square is not possible to 3. Similarly, c square plus 5d square is not possible to 3. If they are not possible, if it is not possible, it is not possible, then what is the possibility of a square plus 5b square? It is either 9. If it is 9, then this is 1. Okay, and if this is 9, then this is 1. Okay, if this is 9, then this unit. If this is equal to 9, then c plus d square root of minus 5 is unit. Okay, so 3 is irreducible, but 3 is not prime. Why 3 is not prime? See, 3 divides 9. Okay, now come to this point. This 3 divides 9. Yes, this 9 can be written as this one, a plus b, a minus b. Yes, so if 3 divides 9, this implies that 3 divides, what is 9? 2 plus square root of minus 5 and 2 minus square root of minus 5. Okay, then 3 divides this. But if 3 divides this one, suppose 3 divides 2 plus square root of minus 5, then 2 plus square root of minus 5 is equal to 3 into there exists a number in z square root of minus 5, say a plus b square root of minus 5. Okay, now taking conjugate and multiplying. Okay, so this is equal to 9. Taking conjugate and multiply, conjugate of 3 is 3, that is 9, and conjugate of this is a minus b square root of minus 5, and multiply this, a square minus 5b square, plus 5b square is equal to, this is a plus b square root of minus 5 into a minus b square root of minus 5, a plus b, a minus b, a square minus b square into square root of minus 5 square. Okay, this is minus 5, so a square plus 5b square, this one. Okay, so this is equal to 1, but a square plus 5b square equal to 1. A square plus 5b square equal to 1. This is possible only when a is equal to plus minus 1, a equal to plus minus 1 and b equal to 0. Okay, if a equal to plus minus 1, then what is 2 plus square root of minus 5, right, is equal to plus minus 3. Okay, so whether these two are equal, it is not possible. This is not correct. Okay, it means 3 does not divide this. Why these two are equal? Since we assume a wrong thing, that 3 divides this, so 3 does not divide this, and similarly 3 does not divide this also, right? 3 divides a into b. See, now see the result. 3 divides A into B, right? 3 divides A into B, but 3 does not divide A and 3 does not divide B. But what is the condition of prime? 3 divides AB implies that 3 either divide A or 3 divides B. Then 3 is prime. Okay, and obviously 3 does not equal to 0 and 3 is not unit. Okay, so 3 is not prime element. 3 is irreducible but not prime. Okay, what are the units of z square root of minus 5? This is plus minus 1. Only 2 element are unit. Okay, so we will stop here. Next lecture we will see some more problems related.